So today, 5.3, it says solving polynomial equations, but essentially actually what we're doing all day today is factoring polynomials. And they're not your simple quadratics. Okay, they're more complicated, the powers are higher, and you have to pay attention to each individual one to decide what method you are going to use. Now, the two key things we have: sum of cubes and the difference of two cubes. A perfect cube plus or minus a perfect cube. You cannot reason out how to factor the sum or difference of cubes. You must have the formula memorized. It is not something you can suss out the answer. I can always tell when students have the answer, have it memorized and have it down, and when they don't. Because if they have it down, they get it right. They don't, I know exactly what the wrong answers always look like from somebody who's not paying attention and who's not doing this and not trying to learn the formula. You have to have the formula memorized. Okay? So the sum of two cubes, a perfect cube plus a perfect cube, is the two cube roots, the two things I'm cubing, plus and minus. So a cubed plus b cubed is a plus b. A squared minus ab plus b squared. If it's a difference, i.e. I'm subtracting the two cubes, it's a minus b, a squared plus ab plus b squared. Often students will use the acronym SOAP. So, same, opposite, always positive. This sign is the same. This sign is the opposite. And this sign is always positive. It's the same as this sign, the opposite of that sign, and then always positive. So this is plus, this is plus, this is minus, it's always positive. If this is minus, this is minus, this is plus, this is always positive. And you have to know what perfect cubes look like. Obviously, x cubed and y cubed, or any power that's divisible by 3, is a perfect cube on a variable, but you have to know your numbers. 1 cubed is 1. 1 to any power is 1. So 1 is any number to any power you want to take it to. 1 is 1 squared. 1 is 1 cubed. 1 is 1 to the 4th. So you can always factor that out. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. And 5 cubed is 125. And for snorts and giggles, you should have 6 cubed, which is 216. But you need to know those. Particularly the first 5, you need to have memorized. You need to be able to look at a problem and go, oh, that's 125. That's 5 cubed. Because if you can't look at it and see 125 as 5 cubed, you can't recognize that you have the sum or difference of 2 cubes. And if you don't have the sum or difference of 2 cubes, it doesn't do you any good if you can't recognize the numbers that are perfect cubes. You have to know. And I can't do that for you. You have to have those memorized. Okay? It's like perfect squares. 1, 4, 9, 16, 25. You need to know that those are all perfect squares. Those are perfect cubes. You have to have those down. Okay. Example problem number 1. Factor. These are all review problems. Get to it. Okay, so the first one, factor out of 4x cubed. You get 4x cubed times 3x squared plus 2x minus 12. And I don't see the factors of 3x squared plus 2x minus 12. Two numbers that multiply to give me 36. Negative 36 and add to give me 2. 6 and 6, 9 and 4. Neither one of those are going to do it. 3 and 12 isn't going to do it, so I don't see them factorable. That one's done. The next one's difference of 2 squares. The next one, you get m plus 3, 2m minus 5. Two numbers multiply to give me negative 30. 2 times negative 15 is 30. Over 1, 6 and negative 5, divided by 2. The 6 reduces. A number of people on the test did this as m minus 5 halves. Nope, that won't work because you won't get the same answer when you FOIL it out. It has to be your denominator times the variable plus or minus whatever the numerator is, depending upon whether this is plus or minus. This is a perfect square. 25 is 5 squared. 49 is 7 squared. To check it, 5 times 7 is 35. You double it, you get 70. It's a perfect square. Difference of two squares. This one, set it up, you get negative 24 and 10. Negative 2 and 12. Divide them both by 8. They reduce down. That's what you get for your factors on those. This is review. This is stuff we did before. This will extend into what we are doing today. Questions on this? Okay. Factor each perfect cube. This is where having the formulas down will save your hide because you can't figure it out otherwise. But you do have to understand my cubes. So the first one, w cubed minus 125. Well, w cubed is obviously w cubed. 125 is 5 cubed. It's a perfect cube minus a perfect cube. We have a formula for that. This is what you have to do. W minus 5 times w squared plus multiply the 2, 5w plus 5 squared. The quadratic on the sum and difference of cubes is never factorable. That's it. You're done. This quadratic here, w squared plus 5w plus 25, is never, ever, ever factorable. So if it's the sum or difference of two cubes, you do the formula, you're done, you're finished, you can't go any farther than this. Okay, on the next one, 8h cubed plus 27. 8h cubed is 2h cubed plus 3 cubed. Knowing your perfect cubes lets you do this. They have to be perfect cubes. You have to know what they are. So I have the sum of two cubes. So I use the sum formula. 2h plus 3 times the first term cubed, or sorry, squared. So that's 4h squared. Minus, because that's plus, so my first one here is minus. Multiply the 2. 2h times 3 gives me 6h. Plus the last term squared. 3 squared is 9. Same idea. 1 is 1 cubed. 27a cubed is 3a cubed. What am I cubing to get each term? It's the sum. So it's the first one plus the second one times the first one squared minus, because it's always opposite of what it was here. Multiply the 2. 1 times 3a is 3a. Plus square the last term. Take 3a and square it. I get 9a squared. It's simple. Follow the formula. If you recognize the cubes, follow the formula. It's not that hard. Okay, 64 is what cube? 64 is 4 cubed. It's 8 squared, but 4 cubed. Minus n cubed. So it's minus, so this is 4 minus n. And my first term, take my first term and square it. Take 4 and square it, I get 16. Plus, multiply the two terms. 4 times n is 4n. Plus, square the last one, n squared. You get n squared. Your middle term comes from multiplying the two terms that you're adding or subtracting. That's where your middle term comes from. You just multiply a and b, whatever those two items are. Learn this. If you learn that, it's a piece of cake. If you don't, you're going to get it wrong. Like I said, when I grade the test, I can tell those that are guessing and those that are doing it. Your turn. Do those. Okay, so the first one is v cubed minus 3 cubed. So v minus 3, v squared plus 3v plus 9. Next one is 2 cubed and 5b cubed. So I have 2 plus 5b times 2 squared, which is 4 minus, multiply the 2 to get 10b, plus the last one squared, 25b squared. Next one is 3 cubed minus 2k cubed. So I get 3 minus 2k, 3 squared, which is 9, plus multiply the 2 to get 6k, plus 2k squared, which is 4k squared. And the last one is 1 cubed plus 4h cubed. So I have 1 plus 4h times 1 minus 4h plus 16h squared. Once again, the quadratic with the sum and difference of 2 cubes, the quadratic portion is unfactorable. You cannot go any farther with that one. It just can't. Okay, factor each 4th degree trinomial. This is just like factoring a quadratic. Your first step is exactly the same, except for one difference. Instead of having x plus or minus some number, you're going to have x squared plus or minus some number. So I still do the same setup, same first step. 2 numbers that multiply to give me 16 that add to give me -8. I get -4 and -4, right? Yeah. So that means this factors into x squared minus 4 times x squared minus 4, which I know is x squared minus 4 squared, but we don't want to do that here because we need to look, can these be factored more? I have the sum of 2 squares. Sorry, the difference of 2 squares, my bad. The difference of 2 squares, which means that x squared minus 4 is x minus 2, x plus 2. That's for that one. And then I have another set for the other one. Now, if you want to rewrite this as squared, you can. If you want to leave it this way, I'm okay with that. You could rewrite this and make it a little cleaner. X minus 2 squared times x plus 2 squared. But if you left it here on the test, I would be just fine with that. So I look at the next one. Same idea. 36 and -13. Be -4 and -9. -4 times -9 is positive 36. -4 plus -9 is -13. So because that's a 4 and that's a square, this is x squared minus 4, x squared minus 9. This only works because it's the 4th power and the 2nd power and then no power. It's just like a quadratic of squares. If the first power, if I have an even power, followed by half of that power, followed by none of that, it's the exact same thing. If that were x to the 6th, minus 13x cubed plus 36, I would have x cubed minus 4 and x cubed minus 9. If it were x to the 10th and x to the 5th, it would be x to the 5th and x to the 5th. Always that way. Now, x squared minus 4, we just did that. Sum and difference of two squares. So this is x minus 2, x plus 2, x squared minus 9, difference of squares, x plus 3, x minus 3. So you can probably guess what's going on with the last one. Two numbers that multiply to give me 9, that add to give me negative 10. Negative 1 and negative 9. Negative 1 times negative 9 is positive 9. Negative 1 plus negative 9 is negative 10. Sum of two squares, x squared minus 1 squared. Drives me nuts that kids always forget that 1 is 1 squared. X plus 1, x minus 1. And then we already did this one, x plus 3, x minus 3. Very similar to what we've done before. Very, very similar to what we've done before. With a little twist. You're essentially doing not a quadratic, it's a fourth degree, but it's very similar to a quadratic. As long as the first power is twice what the middle power is, and there's no variable on the end, you treat it just like a quadratic. It's factors just like a quadratic from that standpoint. Questions on these examples? Your turn, do those. Okay, so the first one is x squared minus 1, x squared minus 25. Whenever the number in front is 1 more than the number at the end, it's 1 in that number, if the last one's positive. So this is x plus 1, x minus 1, x plus 5, x minus 5. On the next one, it factors into x squared minus 4, x squared minus 1, which is x plus 2, x minus 2, x plus 1, x minus 1. And the last one, 100, yes?
The first one, the 25 one, what would happen if I can't use the x to factor and it was a positive? Would it be just...
If you had a plus instead of a minus in between, you can't factor it again. Sum of two squares you cannot factor.
So then,
but if you got a plus instead of a minus in between, you did it wrong.
No, I didn't get that.
Yeah. If you got, let's say this was a plus 26 up here, and you got x squared plus 1, x squared plus 25, you cannot factor it any farther. You're done. It would be x squared plus 1, x squared plus 25. You're done. Remember, this is the difference of two squares. It has to be the difference.
The 1 was negative. Would you do x plus 1?
Yeah, if I could do this one and not that one, yeah, you just do one and not the other. And that might happen.
But that's just
it might. I don't know. Can't guarantee one way or the other. 100 and negative 29. X squared minus 4, x squared minus 25. 25 times 4 is 100. 25 plus 4 is 29. X plus 2, x minus 2, x plus 5, x minus 5. Always try to go as far as you can when you're factoring. Always. Okay, next one. Factor each third or fourth degree trinomial. These ones are different. First thing you want to look at whenever you're doing these problems is there a common factor? On the previous ones, there were no common factors to pull out. But on these ones, there is. First thing you do is pull out a common factor if you have a common factor. My common factor in the first problem is x. Leaves me with 3x squared plus 5x plus 2. And then I have to see, can I factor my quadratic? I might not be able to, but I need to check. 6, 5, that's 2 and 3. Divide both those by 3. I get 2/3 and 1. So I have my x that I pulled out. Don't lose the x that you pulled out. And then I have 2/3. That's 3x plus 2. And then I have 1, x plus 1. This one here, same idea. I can pull out a y. And then I get 2y squared minus 5y minus 3. Set up my x box again. -6, -5, which is -6 and +1. Divide both those by 2. And I get my y that I pulled out. And then I have a -3, so it's y minus 3. And then I have a 1/2. So that's 2y plus 1. And the last one. What's my common factor on the last one? W squared. I have a w in each term, and it's the smallest power that's shared. That's the one I pull out. So I pull out a w squared. Leaves me with 2w squared plus 5w minus 3. And oh, that's the same as that. No, it's not the same. Because it's a +5 instead of a -5. It changes things. Still set this up. -6 and 5, which is 6. And -1. Divide those by 2. And I get 3, and I get w squared times w plus 3. And 2w minus 1. It does make a difference, the plus and minuses. It does make a difference. Okay. So these ones, and you should always look, is there a common factor I can pull out first and then go from there? Sometimes there is, sometimes there isn't. Do those. Okay, so on the first one, pull out your common factor of d. Leaves me with 3d squared minus 7d plus 2. And let's see, this is 6 and -7, which is -1 and -6. Divide those both by 3. And I get a -2 and 1/3, so I get d equals times d minus 2 times 3d minus 1. Next one, my common factor is a b. Pull out my b. And I get 2b squared plus b minus 6. Set it up. -12 and 1. That's 4 and -3. Divide those by 2. I get 2 and -3/2. So I have b times b plus 2 times 2b minus 3. And the last one, my common factor is c squared. Pull out the c squared. And I get 3c squared plus 8c minus 3. Let's see, so that's -9 and 8, which is 9 and -1. Divide both of those by 3. I get c squared times c plus 3 and 3c minus 1. Any questions? Always look for a common factor first. After that, you just have to try different things. You have to be able to look at them and decide what kind of factoring can I do. There's no necessary set way of doing things.